Hi friends, we'll start with current electricity. What is current? Current is nothing but the rate of charge transfer. If Q amount of charge is transferred over a time t, then the current will be Q by t. But this formula gives only the average current, the total charge by total time, this thing. If you want to calculate the instantaneous current at any moment, at any time instant t, then use this one, limit delta Q by delta t, where delta t tends to 0. This gives you the instantaneous current. Of course, the unit is coulomb per second, that is ampere. Now, ampere is typically the order of magnitude of currents in domestic appliances. Of course, but if you look at some natural phenomenon like lightning, there the current will be somewhere in thousands of amperes. That's very huge. However, let's move forward. Experiments have shown that the current passing through a conductor is directly proportional to the potential difference applied across the ends. Okay. Now, V is proportional to I. To remove this proportionality and make it an equation, I'll introduce a constant. Okay. That constant is R. R is the resistance. The unit of resistance is ohm. This is ohm symbol. It is named after a scientist, George Simon Ohm, who gave us the Ohm's law. Resistance is the ability to resist current. Okay. Now, so if more is the resistance, then less will be the current, and if you have less resistance, then current will pass freely. So more is the current. Okay. Resistance depends on the material of conductor as well as dimensions also. This is the formula to find resistance, rho L by A, where L is the length of the conductor and A is the cross sectional area. What is rho? Rho is the resistivity. It is a characteristic of the material itself. So now I can write Ohm's law V is equal to IR as V is equal to I, and R can be written as rho L by A. This is another form of writing Ohm's law. I have to tell you something else. There is something called as current density. What is current density? Current density means just how dense the current is. It is the current passing, the amount of current passing per unit area. In mathematical terms, it should be written as I is equal to J is equal to I by A, where I is the current and A is the cross sectional area. Of course, the current should be passing perpendicular to the area. I mean to say that the area vector should be parallel to the current direction. And J is the current density. The unit is ampere per meter square. Now, you know that if electric field is E, and if I travel a distance L through this electric field, then I'll experience a potential drop of V, E, which is nothing but E into L. You know that, right? This is the potential drop. And from the Ohm's law, I can write the potential drop as current passing into the resistance. Okay. V is equal to IR. So this V, I'll write it as I into R. Now, from this formula, I can write I as J into A. Okay. And resistance can be written as rho L by A from the formula of resistance. Now, from this equation, this L and L gets cancelled, this A gets cancelled, and finally I can write this as E is equal to J rho. The same thing can be written as E sigma is equal to J. What is sigma? It is the conductivity, opposite of resistivity. Rho is equal to 1 by sigma. Take note of this. And this equation which you see is another form of writing Ohm's law only. E sigma is equal to J. Hope everything is clear till now. I'll tell you something. Although this Ohm's law is found to be valid over a large class of materials, even then, for some materials, this proportionality of V and I doesn't hold. Of course, and you can't even ignore these materials because these materials are widely used in everyday circuits. And Ohm's law also has some other limitations, like it's affected by pressure gradients, temperature variations, and I mean, if the temperature increases, then the resistivity increases, hence the resistance also increases. So the proportionality doesn't hold anymore. However, We will be studying the electrical currents in those materials that obey Ohm's law. So for now, take it for granted. Let's move forward. Now you know what is resistance. Resistors of the higher range are mostly made of carbon, and carbon resistors are very compact, cheap, and that's why they are extensively used in electronic circuits. Now the problem here is they are so compact and so small that if I want to write the resistance value on the resistor, I'll have to reduce the font size to such a great extent that probably you'll not be able to read it. So we have a solution for this problem. There is a system to represent the value of the resistance through colors. Observe this table. As you see, each color represents a number. Now, how to remember all these values? I'll give you a technique. Observe this. The thickest color anyone can think of is black. So, it takes the top position. And the lightest color anyone can think of is white. So, you should give the value 9 for it. I mean, it goes to the bottom. Now, the second thickest color that I can think of is brown. So, I'll place it here in the second position. And similarly, somehow try to remember 8 for gray. Now, this part, you can remember it easily. Because here you have WebJor. WebJor, as you know, is the code for remembering the colors of rainbows. You don't have indigo here. Now, this made it easier, right? At least. These are the values for tolerances. Now, what is tolerance? I'll explain you. First, let me tell you how to decode this color codes. Say if you have a resistor here, any resistor will be having 4 colors, 4 color bands. 1, 2, 3, 4. The first 2 bands give the value of the first 2 significant digits. Okay, and the third color band decides the multiplier. I'll explain you in detail. And the fourth color band gives you the tolerance. What is tolerance? Tolerance is nothing but the possible error or possible variation. I mean, take an example. I want to represent a 100 ohm resistor. Okay. Now, the first 2 digits are given by the first 2 colors, and the multiplier or the order, this number 10 power something, this number is given by the third color band, and finally you write plus or minus something. This value is given by the fourth color. Okay, if I want to write 100 ohms resistor, first is 1, so I'll get brown here, and second is 0, I'll get black here. Now brown, black, I got 10 here, and 10 into what gives me 100. So here I should get 1 again, I mean brown. And finally, if there is some, say, gold here, what does gold mean? Plus or minus 5%. 5% of what? 5% of this resistance value. So 5% of 100 is 5 itself. So plus or minus 5. Finally, you should write the resistance value as 100 plus or minus 5 ohms. And let us solve 2 more or 3 more examples so that you get some clarity. Now, help me in solving this. As usual, we'll place some dashes here. First, I have yellow, and yellow is for 4. And next, I have violet, which stands for 7. And next, I have red. Red is for 2. So 47 into 10 power 2 plus or minus, this is gold, right? And gold gives 5% tolerance. So my final resistance is 4.7 kilo ohm plus or minus 5% of this value, 4.7 kilo ohm, 5% of that. This is my resistance value. This is represented by these 4 colors. Let us solve another example. The first 2 significant digits, and here I have the multiplier. First I have brown, so 1 comes here, and black is for 0. Next I have red, so I'll place 2 here. Plus or minus, silver is for 10%. Okay. Now 10 into 10 power 2. This is for 1 kilo ohm, and 10% of 1 kilo ohm is 100 ohms, right? So 1000 plus or minus 100. This is the answer for second one. Third one, same. I have brown here, so 1 comes here. And green is for 5. Orange is for 3, right? So this is 15 kilo ohm. But see here, there's no fourth color. What should I write here? If there is no fourth band, no tolerance band, then just take the tolerance to be 20%. That's what I wanted to say. So this is 15 kilo ohm plus or minus 20% of that 15 kilo ohm. Okay, hope you understood and enjoyed this video. Keep watching. Bye friends.